Okay, now it's time to put our assembly into good use. So we're back in our latest rig file with our character, and we're going to bring in the assembly to use it on his right arm. Now we have to decide exactly where we're going to place this assembly, because we have rotation controls for both the arm and the clavicle. So we could have the assembly located at either place to track the rotations of either joint. To keep things simple and not having to use two of them independently, because you could do that, so, and you could layer different transforms on our pec locator based on different rotation values coming from both joints. But in my case, we're going to keep this simple, and we're going to place the assembly at the clavicle, because the clavicle is a very important part of the movement of the arm. Actually, you cannot raise your arm or put it forward or backwards or down without moving your clavicle. On the other hand, you can move your clavicle without having to move your arm. If you shrug your shoulders, you're basically raising your clavicle without moving your arms at all, or rotating them in this case. So what we're going to do is place our assembly here at the clavicle joint, and we're going to track those rotations and derive our transform values for our pec locator based on that. So let's get started. So let's go to our assemblies tab, and I've created a category here called character rigging course, where I placed our little assembly that we saved in the last lesson. As you can see, I've already made myself up a library of some assemblies that I've been using, and these guys have images, and actually you can just put your own images in your assemblies. It's pretty simple. All you have to do is paint in any painting program a little image that should have square dimensions. Like, let's say I'm used to doing mine at 256 by 256 pixels. You save that out somewhere, and then you come to your assembly, you right click, and you say replace icon with image file, and you're gonna get a dialog that asks you where your image is located. You just select it, and you can that way put some nice icons on your assemblies that hopefully explain a little bit of what they do. So here's our assembly. So let's bring it into the scene, and what I like to do is I like to bring mine into the schematic, especially because we're going to be using them for rigging, so I don't have to just bring them to the scene and then look for them afterwards. So let's bring in the schematic, and we're in the clavicles workspace, which makes sense. That's where we're going to be working. So I'm going to bring it right over here. I just right click on it and drag it without releasing the mouse button, and then release, and we get here our assembly. And as you can see, it gets all its items created right there at the center of the scene. Now, obviously our assembly is rather large at this point, so we can immediately go and in our channels start to reduce the size. And now it's time to place it where we are going to be using it. I'm going to reduce the size even further, not to have like a gigantic assembly here, but let's see. So let's go to items, and let's find the torso controls, and we have this group spine controls IK. We have different groups, okay? And our torso group locator is right there. So I think we're gonna create a couple more group locators. Well, actually just one, to hold our assemblies for the clavicle reading. So let's go and add a group locator, bring it into the torso hierarchy, and we're gonna call this group clavicle readers. Okay, and let's reset its transforms so it also moves over to the exact same location. Now we can take our assembly. Let's find it. Here it is. the assembly direction reader, and we're going to make it a part of this group locator just by dragging and dropping. Okay, so let's expand that and let's see what we have. So there's our assembly. Right now it's still on the floor. So the first thing we're going to do is let's set our drop action to match. We're going to take the assembly root group locator and drag and drop it onto the joint for the clavicle. So everything moves over there. Okay. And the next thing we have to do is we're going to be tracking this guy's rotations. So let's select him and bring him into the schematic. So you'll get the joint and a matrix compose node that we don't need over here. So we're just going to hide it with backspace. And we're going to wire its world rotation to the input rotation world matrix. So this guy will orient itself over to this joint, as you can see. However, I'm noticing something funny that we had not taken into account. Let's select our entire assembly, and as you can see, these 4 locators are the ones that are the markers, and they're not oriented the way we would want them. They're actually lying on a plane on the joint, and I need them to be not parallel the way they are right now to the joint, but perpendicular. So we have to change the orientation of our group locator. So let's find first north. It's this guy over here. So we're going to rotate everything forward 90 degrees. So you can hold down Control and just drag to snap your rotation. There you go, 90 degrees. Okay. And now we needed to rotate it so that they're facing again perpendicular to the joint. So let's find east. Let's say that I want this guy to be east, to be in the front in case I'm looking at the character from this side, right? So we need to rotate again things like so. And now everything is properly oriented. Cool. One thing I might want to do is I'm going to change the display for these 4 markers because otherwise they're going to be a little bit hard to read. So we can just go into the assembly and well, actually I don't need to do that here. I can just change them the display properties. Let's select them again. Display locator shapes. We're going to make them into, yeah, they're going to be cubes. Obviously a lot smaller, and I can later on wire their sizes over to the assembly size property. For now I just want to make them into something that I can more easily read, and I'm also going to make this even smaller. Let's say like that. Okay. Now let's find our tracker. Where is the tracker? Oh, it's down here. He actually should be pointing up there. So what's going on is that he moved on an axis. As you can see, it's the z-axis that is wired to the size of our assembly. So the x-axis is pointing downwards. What I would need him to do is to move on the x-axis right here. Okay, so this is a bit of a problem. Let's start by doing the following. Before we move on with the rigging of this, we've already discovered that our assembly has a few shortcomings, so let's remedy those. Let's create a few extra things inside of our assembly that will help us address these problems. So the first thing I want to do is I want to be able to have this tracker locator position itself on the 3 different axes that he could be tracking on, and also have a negative switch so that he could go on the negative direction if desired. So let's start by doing that. The first thing we're going to need is a couple of extra input channels to determine on which axis our locator is going to be located, and if the axis is going to be positive or negative. So let's do that. Let's create a new channel called tracker axis, and it's going to be, in this case, an integer value. Why an integer? Well, I know that the three axes I could be dealing with could be X, Y, and Z, but we don't have anything that would allow me to have an X, Y, and Z option in here in the data types that I have. There's a string, but then we don't really have any nodes in Modo that can operate on strings yet. So I can't use that. So I'm going to translate this into just integer values, where 1 would be the x-axis, 2 would be the y-axis, and 3 would be the z-axis. Okay, so we're going to, let's say the default is going to be 1. So it's going to be always x, and the minimum is going to be 1, and the maximum is going to be 3. Okay, so now we have that channel, and now let's create another one called negative direction, and this one is going to be a Boolean control. So you just turn it on if you want to go in the negative direction. All right, now we have those two extra channels added. What are we going to do with them? So let's find our tracker, and let's see its z position is coming from this node over here. So we're going to use this value, but we're going to use it differently. We're going to use it depending on which axis is selected and if it's set to negative or not. So let's do that. Let's start by creating a little structure that will tell the system, the assembly in this case, what to do depending on the axis selection. And for this purpose, we're going to use conditional nodes. So let's go to add conditional logic A is equal to B. So I'm going to compare two values. Okay, this node, that's what it does. It takes in two values and compares them based on a rule that you set over here. It could be equal, not equal, greater than, less, greater than, or equal, less than, or equal, and an or. Okay. So in this case, I'm going to set it equal to B. So you're going to have one value compared to another value, and this comparison is going to yield a result of either true or false, because it's either it happens that A is equal to B, or it happens that A is really not equal to B. So you can only have two results. And depending on the result of this test, you can tell the node to output different values. So for example, it says if the test results true, then you could do several things. You could output value A or value B, or the true value, which is a value you set yourself. And in this case, you have here a field to enter the value that you want to output if the test is true. Okay, if the test is false, then you have the same options and also a value to use a particular channel or value to output in case the test is false. So that's what we're going to do. So the first thing I'm going to do is rename it, and I'm going to say axis equals x. When you're in most programming languages and scripting languages, when you write a double equal sign, that means it's a test. You're testing to see if the axis is equal to a given value. So in this case, if my axis is equal to x, okay, which in this case, it's going to be 1. I'm going to leave it as x just to make it more readable, okay? And value A is going to be the tracker axis, of course. And the value I'm testing against is 1, okay? And I need the true value in, so I'm going to add it to the schematic. And my true value is going to be this value we're using right there, okay? So that's our first test. If it results that the axis is not equal to x, then obviously I want to output 0. So the tracker is going to move to 0 units on the x-axis, okay? Now, let's duplicate this node, but without the multiply, okay? And as you can see, it already comes wired here to a couple of channels. This one was okay, the other one was not. And this one is going to do exactly the same. The true value is going to be the same, except this one is going to be testing to see if the selected axis is Y. And lastly, we duplicate this guy. Again, get rid of that. And the true value, again, this guy, but we're testing against Z. And obviously we have to update the values that we're testing against. This one is 1, this one is going to be 2, and this one is going to be 3. Okay? And now we just have to wire them to the correct channel. So let's add the remaining position channels to our node. Let's move this over here. And we can replace these connections with the ones coming out from the test. But before I do so, I also have to test against one more thing to see if the negative direction is turned on or off. So, because if that's the case, then I need to multiply our incoming values by 1. Okay, and actually I could do that test before these guys, so I already have the correct value to work with. Let's move these guys over here, and let's add another logic. Now let's see what a Boolean value is going to return to us. If I select our assembly and go to channels, we'll see that our negative direction channel is set to false. So let's see what that is read as by our test over here. So false is going to be 0, and true is going to be 1. Okay, so we're going to test for 1. Okay, so what we're saying is negative direction equal to true. Okay, so what we're going to do is we need to bring in these two channels, the true and false values, over to the schematic. So if it's true, then I want this distance multiplied by -1. So let's get a multiply node. All right. Let's get some space over here. Oops. What did I unplug? Sometimes this happens. Let's undo that. There you go. Let me move these guys a little bit lower. And this guy, let's leave this guy here. So this guy is going to take in this value and it's going to multiply it by -1. Okay. And we're going to take this test and it's going to say, okay, if the negative direction is true, then we're going to use this, or this is going to be our true value. Otherwise, this one unmultiplied is the false value. Okay, and we're going to replace these incoming values to these nodes, actually the value A, by using this guy's output. Okay, so we're going to take this and pipe it here, there, and there. All right, now we can wire these guys to the channels that are going to be actually using them for the position of our tracker node. So this one is testing for X, so we're going to take that and wire it onto the X axis. This one is going to go to Y, and the last one is going to go to Z. There we go. Now let's give this a little test and see how it works. Just gonna lay up this a little bit better. All right. So let's select our tracker. Right now it's right there at the origin. And let's see, he has all his channels set at 0, which actually should not be the case, because one of these should be testing true. Let's see what the assembly has selected as its axis. 1. Yeah. And then we have our negative direction. So let's debug what is going on. First, we're gonna see what's going on with the negative test. So we can see that we're testing if 0 is equal to 1, in which case it's false. So the false value is 0.16, which is fine. Let's go now to this other node, which is the axis. So we're seeing that we're testing if 0.16 is equal to 1. Aha! That's where the problem is. We are receiving... I plugged this into the wrong channels. These should not be as a value A. Our value A is actually the axis. These should be our true value. So let's move this to true value. Let's move this to true value. And let's move this to true value. All right. And now we can select the value A channels and holding down Control. And we can use Shift to drag them all at the same time to the tracker axis. And it looks like it moved. So let's see. There it is. And now it's positioned in the correct place for the character, which is the x-axis. The nice thing is you can go back to here to the assembly and you can change this to 2. And you'll see that the locator moves here to the back, which is the y-axis. And then if we change this to 3, it moves down here to the x-axis. There he is. Okay, so check him out. Z-axis, Y, X. And if we turn on negative direction, he moves in the other, to the exact complete location. Opposite location. Again, for each axis. Now he's in the front, now he's up there. So, that's working pretty well. Let's put him back in next. No negative. What other things I could add to this assembly to make it a little bit more useful? Well, I'm gonna wire these guys size attribute, because we had wired the original locator size, but now that they're cubes, we don't have something to deal with that. So what I'm going to do is I'm going to take this value over here and wire it to these guys size value as a vector. So let's select all of them. Let's go to display, and in locator shapes, let's control select all these channels and add them to the schematic. So now we have there our size vectors. Okay, and I'm gonna shift select them and shift drag over here. So now the size of the actual cubes is controlled by the display property in the assembly, as you can see. Okay, and we can also, let's say we want to control their wire color from here, so I don't have to be coming into the assembly to change it in case I want to have a different custom color for them. So let's see, I'm gonna select all of them and let's add draw options for them and set the color to user, and let's add this channel to the schematic. And there we go, there's our wireframe color. Let me just move these guys a little bit. And since we're at it, we're going to do the same for the marker. Where's our marker? I mean the tracker, sorry. There's our tracker. Here he is. So let's do the same for him. So we're going to need a couple of extra channels here as inputs. Yeah, I was not going to edit the name. So one is going to be markers wire color, and it's going to be a float value as an RGB vector. Okay, so it's a vector with 3 components. In this case, for color, we don't need the alpha. That's not used by wire colors. So let's go with that and say OK. And let's add a second channel called tracker wire color. Same thing. Now let's just wire these guys to the appropriate values. So for the tracker, we're gonna wire here, and for the markers, here we have wire color, wire color, wire color, wire color. Let's zoom out and with shift wire all these guys to this channel. There we go. So right now they're black, but if I select my assembly and I go to the channels, I can set this to a totally different color. Let's use this really scandalous pink. And for the tracker, let's use some really bright green. And as you can see, there they are. These guys are, yeah, pink-ish. They look darker here in the 3D viewport. This guy seems to be more of a rectangle. Let's see what's going on with him. It's this one right here. Oh, it's missing one of its size channels. Did that happen to everybody? No, just to this guy. Sometimes when you control select stuff, that can happen. There you go. So again, perfect. Okay, I think that's enough additional features for our assembly, and now it's working. So we need to do a couple of things for it to be ready to be reused again in the scene. We're gonna save it first. So let's select it and right click on it and say save assembly. And we're gonna navigate to the folder where we saved it. In this case, I created here one called character rigging course. So let's select that. Select our old assembly, direction reader LXP, and save. You are prompted to see if you want to overwrite the existing file. We say yes. Okay. Now there's one more thing we have to do before we can actually reuse it. I'm going to show you what that is. Let's create a new scene. And in this new scene, I'm going to bring up the schematic again. Let's just keep the perspective viewport here. Let's go to assemblies. Here's the one we created. Let's drag and drop it, and you'll see that it's created using weird transforms. And that's because the transforms that it had stored in it when you saved it were saved along with the assembly. That's not really what we want. So in this new scene, we're gonna take care of that. First thing, let's check which channels values are being saved. Yeah, we have these two funky colors, but that's okay. Let's set the size to 0.1, for example, just to make it a little bit bigger. And let's go to the direction reader and let's reset everything. So it goes back to the origin and the orientations and everything is zeroed. And now let's save it again. So this is now it's going to be its new default state when you load it into another scene. So let's try that. Save assembly. We overwrite again the same file, and that's done. We can now close this file. We don't need it. And let's see what happens when we bring in a second assembly. Before doing so, let's make sure that the names in our file are okay. So let's see, where were we? Where's the torso? Here it is. The clavicle readers. Let's change the name on this guy to group R clavicle reader. Okay. And let's add the size. I mean the scythe, not size. The scythe to all these guys very quickly, just so that when we bring in the new assembly, it also works well. Okay, so we have this one set. Let's bring in a new one. So again, right click, drag, and as you can see, our new assembly is right there at the origin using the values that we had stored, which is perfect. So let's bring this one here, and this one is going to be tied to this joint. Let's bring it in, hide the matrix compose node. Let's move it. Where are you? Here it is. So let's bring in this one over here to our clavicle readers, and let's rename it to group L clavicle reader. I'm not going to rename the rest of the stuff inside for now. I'm going to leave that for later. For now, I just want to align it to the joint. There you go. Again, it's not properly aligned, so let's check where's north. North is over here. So let's rotate this that way. Oops, with control held down. There you go. And let's see where's, now I want to see it this way. So east must be my right hand. East is that way, so I have to rotate it 90 degrees this way. Oops. Looks like that's pretty much it. So let's take a look at where we're at. North should be up, south, east, west. That's cool. And in this case, the tracker needs to be going in the z-axis. So we need to set our tracker axis to 3. Oh, of course, and we need to wire the rotation of this guy down to the input rotation matrix. So let's see where our tracker is now. Oh, he's up. Yeah, that's not going to be the z-axis. Let's see, to x-axis. It's going to be x, but in the negative direction. Perfect. So our two assemblies are all set and ready. The only thing that is left is to get them to follow the character, because of course right now they're just going to stay there in space. As you can see, as the character moves, the assemblies don't go anywhere, and that's not what we need. We need them to follow the character. So let's see what they need to follow. I'm going to select that joint, go to its parent. Let's find the next joint in the character. It's this one. Let's see who that is. Spine 5. So we need to make our assemblies child of spine 5, but not a child in hierarchy. We're going to dynamically parent them. So let's go to setup mode, and let's take the first one and spine 5, and parent. Remember, compensation must be on. And now let's take the next one, clavicle reader, spine 5, and add parent. Let's come out of setup mode, and let's see now what our trackers look like. If I select them over here, just for you to be able to keep an eye on them as the character moves. There they go. All right, and let's also see if our assemblies are doing anything. Our file has a little bit of animation right there on the clavicle on one side. Okay, so let's see what our what our values are looking like for this side of the character. So let's go to the channels. Looks like it has a rather small value here to begin with, which means that my rotations must not be totally exact with the group locator, the one on the right side. Let me redo the matching and redo the rotation part just to make sure I got everything correctly. So north is, this is the other side, sorry, north. It's on that side, so I need to bring it forward. And that was not it. Okay. And looks like the rotations are not working very well. I'm gonna undo the match. I'll redo that later because I have to delete dynamic parent, and because right now this guy, because of the dynamic parenting, is not liking it a lot anymore. But again, the point was to check for the values that we're getting from the clavicle. So let's see, we're gonna go here. Keep an eye on these channels, okay? As we go up, we have some value changes right there. Then as we go down, we have other different value changes too. And now with the clavicle forward, yeah, we have in this case east and west changing values. And let's say for down, we have north and east. Well, we have most of them. Yeah, there's a little offset there that I'm going to fix later. But the point is, everything is working. So that's good. What about this guy? This guy is really zeroed out. So it's just a matter of finding that little offset that the first group locator has and getting rid of it. So we are done with rigging our assemblies into the character. They're done. They're all ready and set to go. The only thing that is left is now we have to rig our PEC locators onto these assemblies. So we're going to do that in the next video.